Welcome to Foundation Mathematics, Plotting and Solving Quadratics. The objectives for this session are to plot a graph of a quadratic function, rearrange a quadratic equation into the form ax squared plus bx plus c equals 0, and solve a quadratic equation by estimation and by using the quadratic formula. A quadratic equation can be expressed as y equals ax squared plus bx plus c, where a, b and c are real numbers and a does not equal 0. A quadratic will either look like this for a greater than 0 or like this for a less than 0. We will begin by plotting a quadratic. Pause the video and have a go at the example on your screen. Press play when you're ready to view the solutions. Let's take a look at part A first. We are required to copy and complete the table of values shown on your screen for the function y equals x squared. So let's solve this. When x equals minus 2, what is y? Let's plug this into the equation y equals x squared. So we have minus 2 all squared, which is of course equal to 4. So let's add the value 4 to our table as shown. Let's now find the value of y when x equals 0. So when x equals 0, we plug that into the equation y equals x squared to give us y equals 0 squared, which is of course 0. So we pop that into the table as shown here. Now let's find the value of y when x equals 1. So when x equals 1, y equals x squared, which equals 1 squared, which is of course equal to 1. So again, let's pop that into the table as shown here. Finally, we're going to find the value of y when x equals 3. So when x equals 3, y equals x squared equals 3 squared, which equals 9. And again, we pop that into the table as shown. So here's our complete table. We can now move on to part B and use our table of values to draw the graph of y equals x squared. Here's a plot of the points. Minus 3, 9, minus 2, 4, minus 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. We can join these points to give us our curve. We're now going to look at sketches of different kinds of quadratics. Here's a sketch of y equals 3x squared plus 0.5. And a sketch of y equals 0.5x squared plus 1. Notice that the graph has kind of widened. And here's y equals 3x squared plus 4x minus 5. The graph seems to have shifted away from the point 0, 0, and it's narrowed again. So different values of a, b and c give rise to different quadratics. If a is greater than 0, the quadratic is convex, as can be seen here and here. The value of c determines where the curve cuts the y-axis. You can see this in the existing curves on your screen, and also in this one. Now let's take a look at another example. What happens if a is less than 0? In this case, the quadratic is called concave, and it takes this kind of shape. Here you can see the value of a is minus 3. And also here, where again the value of a is minus 3. The value of c determines where the curve cuts the y-axis. And here you can see the curve shifting up since c is equal to +1. Let's examine this more closely. What happens to the graph when the value of c changes? So in the first graph, when c equals 0.5, we have that y equals 0.5 when x equals 0. In the second graph, when c equals -5, we have that y equals -5 when x equals 0. And similarly, in the third graph, when c equals 1, we have that y equals 1 when x equals 0. We can also find where the curve cuts the x-axis by estimating from the graph. So let's take a look at the first graph. When y equals 0, we have that either x equals -0.4 approximately or +0.4. In this highlighted graph, the curve doesn't cut the x-axis at all, and therefore it has no roots. In this highlighted graph, when y equals 0, x is approximately equal to either -1.4 or +1.4. We will now briefly take a look at modelling with quadratics. A mathematical description of a real-life scenario is called a mathematical model. It helps us to explore real-life patterns and relationships and make predictions. Projectiles' motions, amongst others, can be modelled by using quadratic functions. So, for example, a ball is thrown from the top of a tower. The height of the ball in meters above the ground after t seconds is given by h of t equals 53 plus 18t minus 23t squared, where t, time, is greater than or equal to 0. So let's take a look at this scenario a little more closely. Here's our tower, and here's our ball being thrown from the top. It's going to follow this kind of motion. In other words, it's a projectile, or it takes the shape of a quadratic as shown. Suppose we consider a point at which the ball passed through at a particular point, say here. H of t denotes the height of the ball above the ground, and t denotes the time that has elapsed. We will now take a look at factorizing quadratics. Let's try factorizing the quadratic shown on your screen. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We can rewrite this equation as shown. Notice that 2x plus 5x equals 7x and 2 times 5 equals 10. So we can split up the quadratic as x squared plus 2x plus 5x plus 10. This allows us to take x plus 2 out as a common factor for the first two terms and for the last two terms. So as you can see, the two lines are equal. We have x squared, 2x, 5x, and 10. And now we can take out x plus 2 as a common factor for both terms, here, and x plus 5 is the other factor. So our quadratic has been factorized. Now for another example. Pause the video and have a go. Press play when you're ready to view the solution. We will factorize using the technique used in part A. So notice minus 5x plus 2x is minus 3x, and minus 5 times 2 is minus 10. So we present the quadratic as shown. X minus 5 is a factor which is common to the first two terms and the last two terms. So we can factorize as shown. And as you can see, the two lines are equivalent. X minus 5 has been taken out as a common factor, and x plus 2 is the other factor. And so we have factorized our quadratic. Now for another example, pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We can express our equation as shown. And so our quadratic has been factorized. Quadratic equations are written in the form y equals ax squared plus bx plus c, with a, b and c real numbers and a not equal to 0. Quadratic equations can have 1, 2 or no real solutions. The solutions to an equation are also called the roots of the equation. So let's have a look at the steps for solving a quadratic by factorization. First, write the equation in the form ax squared plus bx plus c equals 0. Next, factorize the left-hand side. And finally, let each factor equal 0 and solve. So for example, the equation x minus 3 times x minus 4 equals 0 has roots x equals 3 and x equals 4, because these are the points at which the equation is true. So let's take a look at an example first. Pause the video and have a go. Press play when you are ready to view the solutions. Let's take a look at part A first. The equation is already written in the format required, and so we move on to the next step. We now factorize the left-hand side. We need to find two factors of AC equals 1 times minus 7 equals minus 7, which add up to b equals minus 6. This is where the 1 times minus 7 comes from, i.e. AC. And this is where the b comes from, b equals minus 6. The factors that satisfy this property are 1 and minus 7. Since 1 times minus 7 is minus 7, and 1 plus minus 7 is minus 6. So therefore we can rewrite this equation as x squared minus 7x plus 1x minus 7. The first two terms can be factorized as shown, and the last two similarly. As intended, we now have x minus 7 as a factor of both pairs. So we can now rewrite this as x plus 1 times x minus 7, where x minus 7 is the factor highlighted, and x plus 1 is the other factor. So we have now factorized our equation. How do we solve? We let each factor equal 0 and then solve. So if x plus 1 times x minus 7 is 0, then either x equals 7, which will make the equation 0, or x equals minus 1, which will also make the equation 0. And therefore we've solved our equation. Now let's solve part B. We need to first write our equation in the form ax squared plus bx plus c equals 0. So In order to do this to our equation, we simply subtract 25 from both sides, and then we'll have it in this format, as shown. Now we factorize the left-hand side. Factorizing gives us x plus 5 times x minus 5 equals 0. This, of course, comes from the difference of two squares. We have x squared here and minus 25 here. The term minus 5x and the term 5x both add together to cancel out. And finally, we need to let each factor equal 0 and then solve. So x equals minus 5 or x equals plus 5. From here and from here. Now let's solve part C. This is already in the required format, so we can simply jump to step 2. We need to find two factors of AC equals minus 15, which add up to B equals 2. Remember that AC comes from 5 times minus 3, and B equals 2 is from here. Now the factors are 5 and minus 3, since 5 times minus 3 is minus 15, and 5 plus minus 3 is equal to 2. Therefore, we can rewrite the equation as 5x squared plus 5x minus 3x minus 3. And then we can start to factorize. The first two terms become 5x times x plus 1, and the last two terms become minus 3 times x plus 1. So as x plus 1 is a common factor, we can take it out as shown, and 5x minus 3 is the other factor. And so we've factorized our equation, 5x minus 3 times x plus 1. Now we let each factor equal 0 and solve. So if 5x minus 3 is 0, then we have that x is equal to 3 over 5. And if x plus 1 equals 0, then we have that x equals minus 1. Now let's solve part D. We need to do some work on this equation in order to get it into the required format. We first take away 3x from both sides in order to start getting the x's all on one side. And then we tidy up. 5x minus 3x is 2x. The 3x's cancel, so we're just left with 20 on the right-hand side, as shown. And then we subtract 20 from both sides in order to get everything over to the left-hand side. So tidying up, 17 minus 20 gives us minus 3, and 20 minus 20 is 0. And of course the x squared plus 2x stays as it is on the left-hand side. So now we have x squared plus 2x minus 3 equals 0. We have it in our desired format, and now we need to factorize. We need to find two factors of AC which add up to b equals 2. So a times c is minus 3, and of course b is 2. The factors are 3 and minus 1. Since 3 times minus 1 is minus 3, and 3 plus minus 1 is equal to 2. And therefore we can rewrite our equation as x squared plus 3x minus 3, as shown. And now we factorize the first two terms and the last two terms. The first two terms become x times x plus 3, and the last two terms become minus 1 times x plus 3. X plus 3 is common to both pairs, so we can factor this out, and x minus 1 is our other factor. This gives us that x equals 1 or x equals minus 3. Sometimes it is easier to solve without factorizing. Take a look at this example. Pause the video and have a go, then press play when you are ready to view the solutions. Let's solve part A first. Why is it easier to solve this example without factorizing? Take a look at the left-hand side of the equation, where the x is. It's simply a square of the whole expression. So, if we square root both sides, let's see what happens. So let's square root both sides. Square rooting 3x minus 5 all squared simply gives us 3x minus 5, and square rooting 36 gives us plus or minus square root of 36, which gives us 3x minus 5 equals plus or minus 6. And of course this implies that 3x minus 5 equals 6, or 3x minus 5 equals minus 6. Rearranging 3x minus 5 equals 6 gives us 3x equals 11. And then dividing 3x equals 11 by 3 gives us x equals 11 over 3. Similarly, if we look at 3x minus 5 equals minus 6, we can rearrange to give us 3x equals minus 1. And then dividing through by 3 gives us x equals minus a third. So we have two solutions, x equals 11 over 3 or x equals minus a third. Now let's solve part B. Notice that if we square root both sides, we get a nice neat expression on the left-hand side in particular. Square rooting both sides gives us x plus 3 on the left and plus or minus square root of 13 on the right. As shown. So we have that x plus 3 equals plus root 13 or x plus 3 equals minus root 13. And so rearranging the first equation gives us that x equals root 13 minus 3. And if you plug this into your calculator, you should get x equals 0.606 to 3 significant figures. And now let's take a look at the second equation. Let's rearrange this to get x equals minus root 13 minus 3. Plugging these values into the calculator, you should get x equals minus 6.61 to 3 significant figures. Now, some quadratic functions are not easy to factorize. However, they can be solved using the quadratic formula. The solutions of the equation ax squared plus bx plus c equals 0, with a, b and c being real numbers and a not equal to 0, are given by the formula x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Do remember to put the equation in the correct format before you attempt any questions related to this. Now let's have a look at another example. Pause the video and have a go before proceeding. Press play when you're ready to view the solution. So let's solve this. We can solve 2x squared minus 9x minus 1 equals 0 by using the quadratic formula and simply plugging in the values of a, b and c as shown. Now b is equal to minus 9, and we've plugged it in. A and C are equal to 2 and minus 1 respectively, and we've plugged those in. And 2A is equal to 2 times 2. Now we start to tidy up. Minus minus 9 is plus 9, and the bit inside the square root is 89, all over 4. This gives us 9 plus the square root of 89 all over 4, or 9 minus the square root of 89 all over 4. And therefore, x equals 4.608, or x equals minus 0.1085 to 4 significant figures. Recall that the solutions of the equation ax squared plus bx plus c equals 0, with a, b and c real and a not equal to 0, are given by the formula on your screen. Remember that in order to solve a quadratic, you need to put the equation in the correct format first. Take a look at this example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. To find the roots of f of x, let f of x equal 0. So we have x squared plus 7x minus 8 equals 0, and we're going to solve this. We can begin by plugging in b equals 7 to give us x equals minus 7 plus or minus square root of b squared. Here's our b squared. Minus 4ac is 4 times 8. All over 2a, which is 2 times 1. And tidying up gives us minus 7 plus or minus the square root of 81, all over 2, which equals minus 7 plus or minus 9, all over 2. To give us x equals 1 or x equals minus 8. Since x equals 1 or x equals minus 8, we have that f of x equals x minus 1 times x minus minus 8. Tidying up gives us that f of x equals x minus 1 times x plus 8. In this part of the session, we will explore the number of roots a quadratic has. We begin by looking at the discriminant, and especially why it's so important. Now, if y is a member of the real numbers, and it's less than 0, then root y is not a member of the real numbers. Notice that there is a square root in the quadratic formula, square root of b squared minus 4ac. For this function, f of x equals ax squared plus bx plus c, with a, b and c being real numbers and a not equal to 0, the expression b squared minus 4ac is called the discriminant. Suppose a is greater than 0 in our quadratic, y equals ax squared plus bx plus c. In order to find the roots of this equation, we use the formula x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. As we said in the earlier slide, b squared minus 4ac is called the discriminant. When b squared minus 4ac is greater than 0, we have two roots. When b squared minus 4ac equals 0, we have one repeated root. And when b squared minus 4ac is less than 0, we have 0 roots. The case is similar for a less than 0, except the graph looks upside down, so to speak. So let's have a look. When b squared minus 4ac is greater than 0, we have two roots. And again, when we have b squared minus 4ac equals 0, we have one repeated root. And finally, when b squared minus 4ac is less than 0, we have 0 roots. Now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We are required to find the values of k for which f of x equals x squared plus kx plus 8 has equal roots. Now if x squared plus kx plus 8 equals 0, then we have a equals 1, b equals k, and c equals 8. When the roots are equal, we have that b squared minus 4ac equals 0. Therefore, plugging in the values, b equals k, and 4ac equals 4 times 1 times 8, as shown. So now we can solve for k. Tidying up gives us that k squared equals 32. And square rooting gives us that k equals plus or minus the square root of 32. We will now revisit a real-life scenario again, very briefly. Remember that real-life scenarios can be simulated by constructing mathematical models. So, for example, if a ball is struck by a golfer, it may follow this kind of motion. In other words, a quadratic. Let's extend this example. The motion of the ball can be modelled using the equation h equals 0.25x minus 0.05x squared, where h is the height of the ball above the ground and x is the horizontal distance travelled by the ball in meters. So for example, if the ball is here, as shown in the diagram, we have the height h, as denoted here, and the horizontal distance x, as denoted here. We are firstly required to find the height of the golf ball when it is released at a horizontal distance of 1 meters. And secondly, we are asked what is h when x is 10 meters, and is this prediction valid? So let's take a look at part A first. We are required to find the height of the golf ball when it is released at a horizontal distance of 1 meter. So plugging in x equals 1 into our equation for h gives us h equals 0.25 times 1 minus 0.05 times 1 squared, to give us h equals 0.2. Therefore, when x equals 1 meter, we have that h equals 0.2 meters. And now for part B. What is h when x equals 10 meters? Is this prediction valid? When x equals 10, we plug that into the equation for h, as shown here. And of course, x equals 10 has been plugged in here and here, to give us that h equals minus 2.5. So when x equals 10, h is equal to minus 2.5. We need to ask ourselves, is this prediction valid? Of course, height cannot be negative, so the model is not valid when x equals 10 meters. This brings us to the end of this session. If you have understood its contents, you should be able to plot a graph of a quadratic function, rearrange a quadratic equation into the form ax squared plus bx plus c equals 0, and solve a quadratic equation by estimation and by using the quadratic formula. Thank you very much for listening. To understand this topic in greater depth, Do attempt the exercises in your textbook related to it.